Her Majesty Easy Word Science Channel is an online school of science where you visit and learn all the things you need to know about science. We also teach skill acquisition there, just for free. Learn at the comfort of your school, anywhere you are, you can learn at any time. You don't need to pay us any school fees. And remember, the only way you can access us is to visit our channel on YouTube and subscribe. Subscription doesn't cost anything. It means to follow me up so that you can get updates on my channel. When I upload, you'll be aware that I've uploaded. And YouTube will not force you to watch. There is nothing like it is expensive. What you gain in our channel is more than what you spend in watching it. So thank you and visit. If you have any students in the university, in the secondary school, a science student for that matter, this channel is the ideal for helping him out or her out in assignments and most things that give them difficult, preparing them for exam, even WAEC exams, even external exams, IGSE, even Cambridge. Most of them will tackle it very well with the past questions and easy ways to get what you need. Even medical students, we also have in the channel anatomy videos with cheats and easy way to get them. Thank you and spread the good thing.
Okay, hello. Nice to know that you're there. You're live with Her Majesty Easy Word Science Channel, and today we'll be handling our stream 5 for this JAMB 2021. Sorry for being 30 minutes late to the stream time. It was due to an unforeseen circumstances beyond my control. I have an activity that actually overlaps with this time. So, but nice to know that you are there waiting. God bless you all. Remember that today's live stream is going to be very much interesting, and it is you that will make it lively. Your questions is what will make it lively, and it will be the thing that will help you out. I have from question 41 actually here to 50, and I will display them for you to see. Then use the live chat and bring your questions forward when I finish these questions. So first of all, I have to play the questions for today's stream 5.
You don't even know how very special you are. Make it move, make it groove. Make it move, make it groove. Make it move, make it groove.
Okay, that's from now. This 27 is just the first, the other stream. I'll show you the rest of. So from 47, there are some questions we will handle here. Actually, you might see them here. Remember, we handled these ones on the last live stream. So I will continue probably maybe from 41 here. Just see these questions, or I might even answer these ones you have seen there on the screen. So we have surplus questions, of course. See these ones here, 44. Okay. You have it there. That's it. You can see 49 here. Okay, these are the questions. So let's go back immediately to our solving board. We start with the question 41. And you have here JAMB Chemistry Stream 1 notebook already prepared. So let's lift some of the questions. Okay. So this is the question number 41. Okay, it says, which of the following are correctly the products of saponification? Correctly the products of saponification. We should know that saponification is actually the process whereby soap is produced, and it involves the alkaline hydrolysis of esters. So let's check. The option A says sodium carboxylate and alcohol. B says sodium hydroxide and ester. C says carboxylic acid and glycerol. D says salt and water. So which of them are actually the correct products of saponification? Try your ability there in the comment box, but are telling you that you are confused now. If you do saponification, the products that are gotten from it are actually soap and glycerol. That's propan 1,2,3-triol. Then you should know that if sodium hydroxide is used, the soap formed is called sodium octadecanoate, which can be called sodium carboxylate. Of course, the salts of carboxylic acids are called carboxylates. So the correct answer is actually option A. That is sodium carboxylate is the correct answer to this question. Then we take a look at question 42, which says, which of the following is responsible for non-ideal behavior of gases? Which of the following is responsible for non-ideal behavior of gases? You hear about ideal gases. They are gases that obey gas laws, that's Boyle's law and Charles' law, probably at all conditions of temperatures and pressures. But we should know that real gases do not obey these laws. Then the question is, which of these forces or which of these bonds are actually responsible for the non-ideal behavior of gas? When we say non-ideal, remember, ideal gases supposed not to compress. Ideal gases are expected not to have any force of attraction between themselves, and actually the volume they occupy themselves are negligible. So, but in real sense, it is not true for real gases, because a plot of P, V against T or V will not give us a linear graph for all the gases. So what do you think is the answer for the option A? Says van der Waals force. Then option B says hydrogen bond. Then so please, van der Waals forces. Sorry for the break in the transmission, please. The van der Waals forces are actually weak forces. So option A says van der Waals forces is responsible for the non-ideal behavior of gases. So gases that do not obey gas laws at all conditions of temperature is what we refer to as real gases, and such behavior is called non-ideal. So hydrogen bond, no. But remember that van der Waals force means force of attraction just between neutral atoms and molecules. It is not force created by bonding electrons. No, it is a very weak force. It is about 1/7 of the normal bond, or 1/10 of normal covalent bond. Hydrogen bond is also a weak bond. So the answer is A for question 42. Then 43 says calculate the volume of nitrogen for 6.35 grams of copper reacts with a concentrated nitric acid. So this here requires you first to write the equation and balance it correctly. So I have to minimize this so that we can solve. I'll keep it here. So first, so take a look at the solution. Okay. Okay. So we come here and say the reactants first are copper plus HNO3 to give you normal copper 2 trioxonitrate 5, then plus water then plus NO2. Remember that two possible gases can be formed from this equation. If the if this HNO3 is concentrated, then NO2 will be formed. But when this HNO3, for example, if this HNO3 is dilute, the gas that will be formed is NO, that's nitrogen 2 oxide. So nitrogen 2 oxide is formed when copper reacts with dilute nitric acid. But when copper reacts with concentrated nitric acid, NO2 is formed, that's nitrogen 4 oxide, which is a reddish brown gas. This shows that concentrated nitric acid is more powerful oxidizing than dilute what? Than dilute type. So now, first, you need to balance this equation before you answer it very correctly. So first, we need to look at this carefully and check what suits into it. So look up here, we have that copper is we try 2 first, although 2 cannot balance this actually. So although let's try 2 because of this hydrogen. Then when 2 because of this HNO3. So when 2 is here, I think the equation is balanced. Oxygen over here is now 6, so that we have 6 already. No. Oxygen is 6, then plus this 7 plus this 9. So 2 cannot balance this. We go for 4. So checking 4 here, if you put 4 here, that means the hydrogen have to also be compensated by putting 2. And these 2 means that we have this 2 is showing us hydrogen is 4 balanced, but oxygen here is 12. So 12. Okay, 4 times, 12. Then oxygen here is 9 plus 2, which is 10 plus 2, 12. That's correct. Oxygen is balanced. So watch it. Here we have 9. That's 6 plus 2. Okay, 3 times 2 is 6 plus 2 is 8. Plus this is 10. So which means there should be 2 here also. Yes, there should be 2 here exactly. Please don't let this NO here should not confuse you at all. So we have balanced the equation. We write down the stoichiometry. I'll clean this so that you understand it very, very well. The reactant is copper plus HNO3 to give you copper trioxonitrate 5 plus 2H2O plus 2NO2. So we put 4 here, and that gives us a balanced chemical equation. So let's check if it has actually balanced. So nitrogen is 4 here, nitrogen is 4 here, that's okay. Oxygen is normally balanced. So the stoichiometry will now be 1 is to, let me use a contrasting color. The stoichiometry is 1 is to 4 is to 1 is to 2 is to 2. Then you go back to the question. Watch well. The question says calculate the volume of NO2. So that reacts with that's when copper reacts with nitric acid. So they gave us 6.3 grams. The question is not coming out clearer here. So let me bring it out. Okay, they said 6.3 grams of copper was given. So copper and NO2 is what we are relating in this question. Please. So copper and NO2, which means we bring out Cu. Cu will give us 2NO2. And then you go back again. Is the question in mass or mole? You check if the question is actually in mass or mole. So copper was given in mass, then automatically we will change this to mass, and the molar mass of copper is 63.5. So we have over here 63.5 will give you, they asked us this in volume, will give you 40, this should be 44.8. Do you know why? Because 1 mole of a gas at STP is actually 22.4 dm cube. So 22 times 2 will give you 44.8. So it shows that 35 grams will give you 44.8. Then you go back to the mass given to you. What mass was given in the question? The mass of copper given was 6.3. So you now come down here and say 6.35 will give you X. Then you cross multiply. In your cross multiplication, what do you have? You have that 63. But let me save you time here. If you have this type in this forthcoming exam, don't waste your time multiplying. Just watch this particular number very well. Watch the 65 and then watch this 63.5. The only difference here is that here you have that point was moved. This is the same figure, 635, 635. The position of the point differed. Here the point moved here to give you this. So coming to the left hand side, there was movement of point one place backwards. So come here, X will also be moved this point here. Simple. You get your answer, which is 4.48. So in exam, this is what we call point movement. I'm now giving you a cheat. See another illustration. The answer is automatically 4.48, even without your calculator. So I'm in the point shifting of point cheat. If they gave you something like 142, gave you 32.75. Watch. Then the question says 1.42 will give you X. Watch it. Point movement is the same number, 142, 142, only that the point was here. The point was moved 2 places behind to get 1.42. So X is automatically, you move this point 2 behind, 0.3275 should be your answer. So you should learn this point movement. This cheat is very much important to save you time. So you don't need to go and waste time again. But this point movement is applied only when the given number, this value are the same. Please don't apply it when they are not the same. For example, if they ask you 142 gave you 3, what will 2.42 give you? Please don't shift points here because 242 and 142 are not the same. So when the numbers are exactly the same, you move them. So point movement is another cheat. Remember, this live stream covers not only questions but gives you a shortcut to get the answer quick during exams without wasting time. So by so doing, going back to what I just told you now, we have that 63.5 grams of what? Copper gave you 2 times 22.4, because 1 mole of a gas at STP is 22.4, which will automatically be that 63.5 will yield 44.8. Then the given mass was 6.35. You move your point. The point was moved from here to here. Come here and move it. So automatically 4.48, our answer. That is it. So we go back to the question and check if there is 4.48. Unfortunately, it's like I'm having problem in my balancing of the equation. They say calculate the mass of this copper that will concentrated this. Why is it not forthcoming? Okay, let me check my equation if I balanced it well, because these questions are actually mine. I made this question and then I came to this class in a hasty way. So please, let's take a little break. Oh my God. Okay. As you cross-check these things,
Body free, body lotions are great. It's advisable you apply them immediately after taking your pill so that I can lock. What are these drugs that can be used to carry out this abortion and their effectiveness? At what stage would they be applied, and who should be the person in charge of abortion?
First of all, these abortion drugs, they are drugs, of course. I know many of us, we may have heard about them, we may even know them, but we want to talk about them and let you know the pros and cons of using them. Okay, so first of all, we have contraction of muscles, yes, uterine muscles, and that's myometry. It has some experiments and it's nice fun. So subscribe.
Okay, nice to know that you are still there. Remember, you are still live with Her Majesty Easy World, and I'm handling you on the live chat here for your exams that will come up this Saturday, of course, in chemistry. This is actually our penultimate, that's second to the last revision class. We have another one tomorrow for biology, 2:30. Next tomorrow being Friday, still 2:30 for chemistry. So endeavor to be here on time and also invite your friends. Don't forget to share these videos. Don't be selfish with success. Spread the light and never you be an opaque object. God bless you, for Her Majesty really value you. So we go back to our solving board. So we have actually handled this. We will go to that stream. Okay, this is where we are, of course. So please, let's check this question. They say, calculate the volume of NO2 a hair produced. My solving was actually correct. It shows that there is no correct figure, please. 4.48, which is not there in the option. So the correct answer should be, because they gave us 6.3 grams of copper and 64 grams. So from our solving is very, very correct. Please, this is the correct answer. So pardon me, I was in a haste. I couldn't put the correct option there. So please, that is the pattern. So among the options provided, there is none of them that is actually serves as the correct answer. But that wouldn't stop us from going to the next question. So we'll clean off our board. So we lift the next set of questions. They are here. That's question 44 and 45. Which of the following will decrease in mass on exposure to air? It's not okay. On exposure to moist air, which of the following will decrease in mass when you expose it to air? They said A, sodium thiosulfate. Then B says calcium nitrate. Then zinc chloride. D says cobalt 2 chloride. This question is just asking you if you know what we call the liquescent hygroscopy and efflorescent. They say decrease in mass. It means that the thing will react to the environment by losing its content and not gaining. So as we all know, the liquescence absorbs moisture, and when they absorb moisture, it means that their mass will drastically increase, of course, automatically. So any deliquescent that is there cannot be the correct answer. Then hygroscopic substances also absorb moisture, but not large enough to form solution in it. So the liquescence and hygroscopy are out of the options. Rather, the only thing that will decrease in mass should be an efflorescent. And a good example of efflorescent is washing soda. That sodium trioxocarbonate 4 decahydrate. Unfortunately, it's not here in the option. Do you know that another example is also sodium thiosulfate? So sodium thiosulfate is also an efflorescent. It loses water of crystallization when exposed to atmosphere. So the moist air there is not even necessary. What matters is that you exposed it. So on exposure, sodium thiosulfate, that's Na2S2O3, is a pure efflorescent. It loses water, therefore the mass will decrease. Please, option B, calcium nitrate is a strong deliquescent. Zinc chloride is a strong deliquescent. Cobalt 2 chloride is also either a deliquescent or a hygroscopic substance, depending on the whether it's hydrated or the decahydrate or the tetrahydrate or the dihydrate form of it. But just know that cobalt 2 chloride is not an efflorescent. So the correct answer, I said, is option A. It's like we are dealing with A throughout today. Then we come to number 5. If the rate constant, watch the number 5 please. If the rate constant of a reaction is K equals A raised to power 2 multiplied by B raised to power 0, that's anything silent is 0. What is the overall order of reaction? In order of reactions, we have reactions are usually in 0, first, second, and third order, of course. Then the overall order is for you to just sum up the powers of the reactants and the products. Remember that this A means the concentration. This is also the concentration of B raised to power of the coefficients. So the answer is simply add 2 plus 1. So what is here is actually 2 plus 1 that is silent. So the overall order is 3. The overall order for the reaction is 3. So we are done with this. We go to the next question. So we remove this, get our board cleaned up. So to lift the next question, we have this here. Okay, we have answered this question. Okay, this is just the one we answered now. Okay. So don't worry about that 27. I've answered that one in a separate stream altogether. So number 46 is what we are looking at now. And the question says, the delocalization of pi electrons of benzene enables benzene to undergo A, substitution reaction, B, addition reaction, C, hydrogenation, D, molecular disruption. Please, do you know what we mean by delocalized pi electrons? Let me now concentrate on a bit aromatic compounds. Let us see small part of aromatic chemistry. Chemistry of the aromatics, meaning chemistry of benzene and its derivatives. Benzene, as we all know, have this shape. Is a hexagon. So this is the shape of benzene. Then benzene have alternating double bonds inside each one. Inside, after the double bond, you have single. After single, you have double. After single again, you have double. Then this resonates. It is not within this place. And remember, pi orbitals are used to form pi bonds. Meaning, if you come to any compound that have single bond and double bond, let's say this, in single bonded there is no pi orbital, there is no pi electron. This is just we call sigma bond. That is strong bond which cannot be broken by addition reaction, and these are the bonds found in all alkanes that are saturated. But when you come to an unsaturated compound that have double or triple bond, in any double bond, one is pi bond and one is sigma bond. But in any triple bond, one is sigma and two are pi bond. So between two carbon atoms, you have maximum of one sigma bond and a maximum of two pi bonds. So unsaturated compounds have pi bonds. So seeing benzene here, benzene have a double bond and also a single bond. So by the nature of chemistry, because of that double bond, benzene is supposed to undergo addition reaction. But you know what? Benzene shows an unusual character. Benzene is unsaturated, of course, because of the presence of the double bond. Of course, there are three double bonds in one benzene molecule. But unfortunately, benzene undergoes substitution reaction. That is an unusual character of benzene. Being unsaturated is supposed to undergo more addition reaction than substitution reaction. But benzene undergoes substitution rather than addition. The common substitution reaction of benzene is Friedel-Crafts substitution, which involves acylation and alkylation, addition of acyl group and alkyl group, where we have the acyl halide as the source, the acylating agent. We will keep that for now until you get to the level. If you get to this level of the chemistry of hydrocarbons, please don't forget to contact me. You can indicate in the comment box on any of my videos, or you can reach me on +234 7065166217. That is +234 7065166217, so that I will help you out in the chemistry of aromatics. But I'm glad you have gotten a bit what I want you to get in this point. Now, why will benzene undergo substitution reaction more readily than it undergoes addition, despite the fact that it is unsaturated? Why is it unsaturated? Because of the presence of the double bonds. At least there are 3 double bonds in the molecule. The reason is because of the fact that this particular structure we have here, let me draw the alternative. If we have another one looking like this, okay, let me actually clean off. Okay, this, and this. These shapes are actually distracting me. Yeah, I want you to know that this double bond can change position. Remember, the double bond is here. It can come here also, and when it comes here, that's here, this one resonates. This particular one that is here has been here, such that this one that has been here will now come here, and that double bond is here, and this one that has been here will go over here. So this is what we call resonance structure of benzene. Okay. So this is where the double bond has been. Then here we complete our structure well. So here it shows that this double bond, remember I said that double bonds are actually formed by pi electrons. That's pi orbitals overlap, lateral overlap. If you have something like this, triple bond, like, remember that the one in blue is sigma, then the other ones surrounding it are called pi. They are formed by lateral overlap. So when we have lateral overlap, pi bonds are formed, and the orbitals here are actually pi orbitals. So the orbitals responsible for this double bond in benzene ring is not stable, it's not one place. It shows that it resonates, and because of that, a summary of benzene structure can be gotten by this. Drawing the circle to show that this thing can come here, this one will come here. The only thing is that any benzene ring must have alternating double bond and single bond. Alternate means after a double bond, there is a single bond, after single, double, after double, single. You cannot see double together. So that's the rule. So the electrons of the pi here, that the electrons of pi orbital are delocalized, meaning they are not specific, they are not one place, just unlike this compound, where this double bond for this particular compound is here. It doesn't change so frequently. That's in open chain compounds. Whenever you see the pi orbitals or pi electrons, it is not delocalized, meaning here the electrons change, and that gives it this ability to undergo substitution more readily than addition reaction. And I told you that the common substitution reaction it undergo is one we call Friedel-Crafts substitution, even sulfonation, to mention but a few. Don't forget to contact me when it is time. Please, we now see other questions. So the answer, before we go to other questions, let's try answering them. So the answer to this question is the localization of pi electrons of benzene enables benzene to undergo substitution reaction. And I told you earlier that this is unusual of benzene. Benzene is supposed to undergo addition. Why? Because it's unsaturated, but it undergoes addition reaction in a more difficult, higher condition, extreme conditions than it undergoes substitution reaction. Okay, so for the next question, let me now hear you out. Please, I need your questions if you are there online before we now complete the remaining, I think the remaining 3 questions. That's 47, 48, 49, and 50. That's 4 questions actually if you include everything. Bring your questions. But if you don't have any, I will now continue from these ones here. These questions here, I will continue from them. You see them. Last time we stopped at question 40, where we answered which of the following is an ore of tin. We said it was cassiterite in our last stream. Here, when you pass a stream, the 41 is over there, as you can see. Question 41. Then you have 42. We have 43. We now turn over to question 44. So when we answer these questions, if you don't have any question, it means that today's live stream is actually concluded. But it will be nice if you give me your own questions. You can also try these ones here, these questions to help you. Okay, so let's take a little break. So today we learn how to make disubstituted compounds of benzene. A disubstituted compound of benzene plus one remains metal. So this is M dichlorobenzene, while this is now P dichlorobenzene because 1 4 represents. Let's see the next example. Okay. Benzene. Then dimethylbenzene is commonly called xylenes, but the CH3 CH3 are in 1,2 position. Therefore, this is called O-xylene. This one can now be called M-xylene, and this is called. This is the vertebral column. So we will take a look at the bones that makes up the skull, the trachea here. So that's where your ear should be. Let's place the ear there. Okay, see, that's where the ear is supposed to be. It is the temporal. First, let's clean the board.
Hi, my name is Catherine, and this is the Majesty is a Word Science channel. I'm a subscriber to this channel, and yeah, I've watched all his videos. It's like totally amazing. I watched his first DIY video on body lotion, and yeah, I'm using the product. It's like very good. This will like nourish your skin, and it will bring out the beauty in you. Remember to subscribe to Some Majesty is a Word Science channel on YouTube, and there you'll find a lot of amazing videos, and yeah, they are very educative.
Hello viewers, subscribe to Sir Majesty Easy World Science Channel.
And Omega.
Her Majesty Easy World Science Channel. Hello viewers, subscribe to Her Majesty Easy World Science Channel.
And Omega.
Her Majesty Easy World Science Channel. Hello viewers,
For biology,
subscribe to Her Majesty Easy World Science Channel.
okay, I saw your questions. You say, can this be used to remove terpentine? I wouldn't confirm yes or no. You should just know the nature of coffee, if it is actually uh, a protein and does it dissolve in terpentine. It shows the solubility of the stain in the solvent determines whether it can remove it or not. Then someone said the biology language or whatever, I rather call it science language. Please, for you to get a little introduction to the science language, you watch my video here at Her Majesty Easy World Science Channel that it says how to answer strange questions. In that particular video, I treated a little bit of the science language on how you can tackle some questions that you never know by the origin of the word that made them. So that's it. Watch it. Then the other person, then you can come online tomorrow. Yes, tomorrow by 2:30, I will handle biology. Come with your questions. When I'm attending to your questions, I'll give you the languages gradually because, for example, biology, bio means life, logy is to study. So if you have given the question where you know that bio is life, you can easily say something. So for your questions, please, I'm waiting on, but as I wait for your questions, for you that asked about the coffee and coffee stain and terpentine, I'll get back to you on Friday. Make sure you join me live. I wouldn't give you a wrong answer, please. So we have some of the questions here. I am deficient in question. So please, you see the question number one, actually, I think is very easy. A substance which cannot be split into simpler units by an ordinary chemical process is called, this is just nothing but element. Then question number two here says, which of the following is not among the coinage metals? Please look at it. That coinage is major thing there. That's the topic sentence. The topic sentence is just that coinage metals. So they say which one is not a coinage metal. I'll tell you the answer here is check well. The coinage metals are actually the group 1B, and mercury is not among them. So mercury is not a coinage metal. It's not used for making coins. It means just those of them that are used for making coins, and they belong to group 2B. Yes, of course. Is it group 1B in the periodic table? That's conventionally the group 11, and is made up of okay, I will explain more when I come there. So take a look at that of coinage metals. Please. Okay, for coinage metals, I said they are what? They are actually metals used for making coins, and they include copper, silver, and gold. And their group in the periodic table, I say they belong to group 1B, conventionally known as group 11. That's when you count from 1 to 18. Remember, we have 18 groups in total, out of which 10 are transition group and 8 main groups. So, and one thing about this coinage metal is that their configuration ends in ND10 and N plus 1 S1. Just don't get it confused. I'll tell you what I mean by that. So they have the configuration that ends in ND10 and N plus 1 S1. Like copper, is in period 4. Therefore, it ends in 3D, 10, 3 plus 1, where 3 here is N. So 3 plus 1 is 4, 4S1, which means silver will end up in 4D10. That's for silver. Here is for copper. Silver will end in 4D10, 4 plus 1, 5S1. And gold will end in 5D10 and 6S1, 5 plus 1. That's how it is. They all disobey half bow. Remember the order of filling of orbital. 4S supposed to be filled up before electrons should go to 3D, but this is not applicable for the coinage what metal. So that's their unusual property. So please, more of your questions. If you don't ask questions much, I'm ending this live stream. Bring your questions, bring your questions. Then as we wait for you, we'll play other live streams, the other past questions. We'll play some of the videos of the stream 1, 2. I start from stream 1 questions. Let me check if I can still find them. Yes, I think they are here.
Came true. You don't even know how very special you are. Make it move, make it groove. Make it move, make it groove.
Good afternoon.
Make it move, make it groove.
The difference, okay. Okay, I got your questions. You say, what's the difference between amine and nylon? Nylon is a polymer, please. Nylon is a polymer, is an addition is a condensation polymer, please. But amine is a homologous series of compounds. So if I get your questions right, I've answered you. Nylon CCCs, that's the common condensation polymer we have together with terylene. The nylon CCs, I think, is gotten from hexane 1,2-dioic acid and hexane, I think 1,2 the canoic acid. I can't recall, but there is an amino compound in that nylon CCCs which is containing 6 carbons actually, and are collectively forming a polymer known as nylon CCCs. Then, which other question did I? You say, how do you calculate number of moles? Okay, thanks for your question. It depends on the question given to you, please. How do you calculate number of moles? Simple. How to calculate number of moles? It depends. You can say moles equal to given mass over molar mass. So it depends on the question, please. You don't just tell me how do I calculate the number of moles. So in this case, where GM is the cheapest way, is the given mass. Ym is the molar mass. Like if I tell you how many moles are there in 4 grams of sodium hydroxide. First, the molar mass of sodium hydroxide in brackets, sodium is 23, oxygen is 16, of course. So oxygen is 16, hydrogen is 1. For this exam, you should be able to master some of these things. That hydrogen is always 1. So the molar mass of this is 40 automatically. So you now go back to this and say N equal to Gm given mass. The given mass was 4. The molar mass was 40. So 4 over 40 is 0.1 mole. So please be specific when you ask question. Nylon 666, I'm trying to remember, but just know that it's hexane 1,2 diol makes up is one of the polymer bonds. Remember that nylon 666 is a condensation polymer, of course, not addition polymer, together with terylene, and I think there is an adipic acid there also. So more of your questions. I'm waiting. Your success is my topmost priority. And as far as I'm concerned, I'm wishing you the best of luck in this forthcoming examination. Ask me questions so that you can get the best of me, please. As we wait, we take some of the questions. I'm not seeing your questions that is still there online. Ask your questions in chemistry. I've attended to the questions I see. So remember, tomorrow chemistry comes live tomorrow. Sorry, next tomorrow. Tomorrow should be biology, same time. Tomorrow should be biology, same time. I'll bring some of the questions now. Some of the questions, okay. Hexane dioic. Then from here we take number 3. Okay, number 3 here is saying in methane 12 grams of carbon reacts with sulfide. Okay, 12 grams of carbon reacts with 4 grams of hydrogen. In hydrogen, your question says what there? Say, can nitrogen exist in liquid form? Of course, nitrogen can exist in liquid form. Please, nitrogen exists in liquid form. That is what we call liquid nitrogen. pH level will be solved for. Okay, that's solving of pH. pH questions. Okay, for pH, you know that pH is the measure of acidity or alkalinity of a particular system. So for pH, I got your questions, please, and I'm attending to them. One of my streams, I just gave you the formula for pH. Remember that pH is nothing but negative log of hydrogen ion. So the pH level, it is either acidic or basic. You use pH scale or you use pH pH pepper, of course, that have some calibrations with it and gives you a kind of reference point for color changes. So then calculating pH level, you should know that the normal strategy that 7 is 0, that from 0 to 7 is acidic, then 7 to 14 is basic. So we have 1, 2, 3, 4, 5, 6. Then here is 8, 9, 10, 11, 12. We extend this a bit. 13 and 14. So just know that pH level is measured by, if you have 1, 2, 3, 4, 5, 6, 7 is acid. When you use your pH pepper or pH scale, you will know that. And this depends on the hydrogen ion concentrations. Then the other person say, can nitrogen be liquid? Of course, nitrogen can be liquid. There is what we call liquid nitrogen, of course. Please, you can liquefy nitrogen. And remember, it's comparatively inert. Okay. Still here, we still have about 4 minutes to go. So get us your questions, please. There are other questions concerning this. Let's play stream 2 questions, please, for the last stream. We are showing you stream 1. Okay.
Came true. You don't even know how very special you are. Make it move, make it groove. Make it move, make it groove. Came true. You don't even know how very special you are. Make it move, make it groove. Make it move, make it groove.
Okay. I saw this question just now. You said, what is the use of liquid nitrogen? It's used, is inert actually. It's used to produce inert atmosphere for some reactions that will involve where oxidation is not needed, where you need to prevent oxidation. Then it's mainly used for cooling. So liquid nitrogen is used for cooling. Someone asked what's the use of liquid nitrogen, and I've attended to that right now. I say liquid nitrogen is used for cooling. Now let's play with the stream 4 question. If we can see it. I don't know if I can see it. Or stream 3 rather. Okay. Okay, this was the display for stream 1. Okay.
Can't even know how very special you are. Make it move, make it groove. Make it move, make it groove. Make it move, make it groove.
Okay, you talked about stoichiometry. Okay, someone talked about stoichiometry. Please watch my video here. I have prepared a video for you on stoichiometry. Watch it here on this channel, Her Majesty Easy World Science channel. If you can't find it, try to chat me up on WhatsApp. I've given you my number on this live stream. Find out, chat me and tell me to send you the link. I'll give you the link as far as stoichiometry questions are concerned. If you have anyone, type it. I'll handle it. But just, I'll still give you some guides on the stoichiometry with this few extra time actually, because our time have elapsed. And remember, these are the questions we handled today.
Came true. You don't even know how very special you are. Make it move, make it groove. Make it move, make it groove. Make it move, make it groove.
Okay, these are the ones we handled today. So for stoichiometry,
Even know how.
you should just know that stoichiometry. the heaviest elements for you that asked, I heard you. It depends on, are you talking about artificial elements or naturally occurring? For naturally occurring elements, I think the heaviest atom should be uranium-238, of course. For naturally occurring, that's the heaviest element. You didn't say density. Remember, you say heaviest. So it should be uranium-238 for uranium-238 should be heaviest for naturally occurring. So coming to stoichiometry, I say that the control center is going to. So you are either moving from 1 mole to either move from mole to particle. That's Avogadro's number times 10 raised to power 23, or you move from mole to volume 22.4 dm cube at STP, or you move from mole to mass, that is for molar mass. Please, so while solving questions on stoichiometry, first you should know whether they are relating mole to particle, mole to volume, mole to mass. So this will guide you. Then remember, you can also move from particle to volume and also move from volume to particle, then move from mass to particle and also move from particle. So directions are possible. You can also move from mass to volume and also move from volume to mass. Watch me now. If I say, what is the molar mass of a gas if 5.6 dm cube of it weighs 32? You see, I gave you volume and mass. So you compare this and mass. So you will now say whatever 22.4 dm cube gives is the molar mass, because this shows that molar mass will give you 22.4 dm cube for gases. Then if the question says how many carbon atoms are present in 24 grams of carbon, grams, that means I'm discussing mass and the particle. So I will relate the molar mass of carbon, which is 12, means 22.4. Then if the question says what is the number of moles of gas that will occupy 6 or less, that will occupy 11.2 dm cube? Mole. That means I'm moving from 1 to 22.4. So the thing there is that when you watch this video, I assure you, you will not get lost again. The name is Stoichiometry Calculation Made Easy. So thanks for being here today, and tomorrow is another day. By 2:30, biology comes live, and remember that you should come with your questions while coming and invite your friends. I really value you so much, and your success is one of my topmost priority. I keep telling you that. So please, next time we are going to meet should be exactly tomorrow by 2:30.
I love you. Thank you for watching. I love you. Thank you for watching.
Okay, Sa Majesty Easy World Science Channel is an online school of science where you visit and learn all the things you need to know about science. We also teach skill acquisition there, just for free. Learn at the comfort of your home, school, anywhere you are, you can learn at any time. You don't need to pay us any school fees. And remember, the only way you can access us is to visit our channel on YouTube and subscribe. Subscription doesn't cost anything. It means to follow me up so that you can get updates on my channel. When I upload, you'll be aware that I've uploaded. And YouTube will not force you to watch. There is nothing like it is expensive. What you gain in our channel is more than what you spend in watching it. So thank you and visit. If you have any student in the university, in the secondary school, a science student for that matter, this channel is the ideal for helping him out or her out in assignments and most things that give them difficult, preparing them for exam, even WAEC exams, even external exams, IGSE, even Cambridge. Most of them will tackle it very well with the past questions and easy ways to get what you need. Even medical students, we also have in the channel anatomy videos with cheats and easy way to get them. Thank you, and spread the good thing.